First of all, hello for everyone, and thank you for joining us today. Let me first introduce myself. My name is Andrei Abramov, and I'm your host for today's webinar. At ArangoDB, I'm working as a development lead of ArangoSearch team for approximately 1.5 years. And the team itself is responsible for development ArangoSearch, the underlying search engine behind the ArangoSearch, and further integration into ArangoDB ecosystem, namely cluster, transactions, and eQual itself. And today I'm going to present you probably the biggest feature we have introduced in the recent 3.4 release. It's ArangoSearch, search engine natively integrated into multi-model database. And we're going to talk about the motivation behind having a search engine in ArangoDB, the view concept in general, and the features ArangoSearch brings to ArangoDB, like analysis, search, and ranking. And afterwards, there will be a demo, so you can see how it actually works. But before diving deep into search engine business, let me first give you a short overview of what ArangoDB database actually is, so that we can check how search engine can enhance its functionality. Actually, ArangoDB is a multi-model database natively designed to efficiently handle 3 different models, namely key value pairs, documents, and graphs. And ArangoDB can be deployed in different modes. It's single server, master slave replication, and cluster. ArangoDB cluster scales horizontally so that one can store and process really huge amounts of data. And all supported data models are exposed in AQL. It's acronym for ArangoDB Query Language, so that one can combine it seamlessly. All 3 data models can be combined seamlessly in a single query. Essentially, AQL is easily understandable with SQL background, which is an industry standard. Okay, now without further ado, let's talk about ArangoSearch. And as I mentioned before, it's a search engine which is natively integrated into database core, which allows user to combine different data models with search functionality in a single AQL query. And the motivation behind having such functionality in ArangoDB is related to the fact that nowadays every single user is faced with huge amounts of semi-structured and unstructured data, and when performing a query, one has only vague assumption of what he's looking for. That means when executing a query, he is not only interested in data sets with satisfying search criteria, but particularly the most relevant ones. And in order to achieve that, ArangoSearch combines 2 information retrieval models. It's Boolean retrieval and generalized ranking retrieval, so that each document approved by Boolean model gets its own rank from the ranking model. Actually, the integration of search engine in ArangoDB is different compared to the other well-known databases like ArangoDB or Couchbase. Usually, there is an index instance per queryable data source like collection, but since ArangoDB is designed to be a multi-model database, natively designed, it allows you to efficiently handle document collection, key value pairs, and even graphs, which in turn composed of multiple collections. ArangoSearch is exposed as the new view database object, which is meant to be treated as another data source accessible via AQL. So ArangoSearch view doesn't store any data itself, but only references to the actual documents stored in underlying collections. And a single view instance may contain documents coming from different collections, making it possible to perform really complex federated searches, even over the whole graph. Apart from federated search, ArangoSearch brings 2 new steps to a regular ArangoDB data processing workflow, namely analysis and ranking. The ranking in general is the process of evaluating document rank or score according to a specified search criteria, and I'm going to give you some intuition on ranking a bit later. Analysis, in turn, as the part of DML processing flow, is meant to be treated as transformation of field value in a document into a stream of tokens. And the definition of token depends actually on the application. And for example, in case of text processing, one can treat tokens as words in a phrase or in the sentence. So the basic example of analysis is just splitting a sentence into individual words. And on the slide, you can see an example of how one can benefit from analysis both by ArangoSearch to regular AQL, In 3.4, we introduced new tokens function, which returns you an array composed of tokens produced by a specified analyzer. And I will show you some live examples a bit later. So in AQL, one can query a view similar to a collections, with the only difference that data source specific AQL extensions are accessible via a new search keyword. For example, ArangoSearch AQL extensions allow to perform complex phrase and proximity searches, combining them into a set of operators supported by AQL and even other AQL functions. Regardless, the query looks pretty similar to a usual collection query. There is a subtle but fundamental difference between the search and filter keywords. Let's talk about that a bit. So on the slide, you can see two execution plans of two queries that serve the same purpose, namely getting all drama movies from a view and collection correspondingly. So in the context of ArangoSearch, filter always means post-processing. So it doesn't use any indices at all, but rather performs a full scan of the result produced by corresponding view expression. And in contrast to filter, search keyword does guarantee to use ArangoSearch indices, allowing the most efficient execution plan. And search expression has a number of noticeable differences compared to filter expression. First of all, search expression is meant to be treated as the part of the for loop, not as an individual statement. So there is no in the first execution plan, there is no other nodes below the enumerate view node. Apart from that, there may be only one search expression related to a corresponding ArangoSearch view expression. And though ArangoSearch view contains documents having at least one index field, such expression works only with indexed attributes, and non-indexed attributes are treated as non-existent. And as was mentioned before, data source specific AQL extensions are allowed only within the context of such expression. In general, it's always recommended to prefer search expression over the filter expression. That's actually almost always possible. So now it's time to discuss ranking. And for understanding of ranking, it's pretty complex, and it requires some advanced knowledge. In this section, I'm trying to give you an overview of ranking model in ArangoSearch and how ArangoSearch uses it for measuring document relevance. The ranking in general is the process of evaluating document score according to search criteria. And for text processing, ArangoSearch uses so-called vector space model. And it postulates the following. So in the space formed by the terms of the query, document vectors that are closer to a query vector are more relevant. And practically, closeness is expressed as the cosine of the angle between two vectors, namely cosine similarity. So in other words, we treat documents and search criteria as vectors and evaluate cosine of the angle between them. Then we can sort documents by the evaluated cosine value, and finally retrieve documents that are closer or more relevant to a specified query than the others. So let me give you an example. Assume that we have a dataset composed of 3 documents. And our goal is to find the most relevant documents according to the given query, to the specified query. So basically, we're looking for documents that contain at least 1 out of 2 words, quick and brown. Then for this query, let's imagine 2-dimensional space formed by these words. And let's put, first of all, the query onto the graph. And let's afterwards put every single document onto the graph as well. And from this plot, it's clear that document 3 is the most relevant to the given query, since cosine of the angle between vectors representing document 3 and query is equal to 1. And basically, in order to compute such cosine value, we have to evaluate vector components at first. And there are a number of probability and statistical weighting models in general, but As for 3.4 release, ArangoSearch provides two probably the most famous schemes. There are Okapi BM25 and TF-IDF. Under the hood, both models rely on two main components. The first one is term frequency, and in the simplest case is defined as the number of times that terms occurs in documents. And inverse document frequency, which is a measure of how much information the word actually provides. So in other words, whether this particular term or word is common or rare across all the whole document corpus. And in AQL, both weight models are exposed via corresponding functions BM25 and TF-IDF. Please note that both functions accept corresponding AQL loop variable as the first argument. But in 3.4, these functions have a number of limitations as well. So first of all, that it's not possible to use evaluated score value in generic AQL expressions like filters or calculations. And these functions must be used in a sort statement related to an ArangoSearch view. But for information retrieval experts, ArangoSearch provides easy and straightforward way of fine-tuning weighted schemes at query time. For example, in the query below on the slide, you can see that BM25 accepts three coefficients as the parameters and may be easily turned into different weighting scheme. In that case, it's BM15. So another crucial point of ArangoSearch is ability to fine-tune the document score evaluated by relevance models at query time. That functionality is exposed in AQL via corresponding boot function, and this function accepts any other valid search expression and corresponding so-called boost factor. And it does nothing but imbue the provided boost value into search expression context, making it available to for the scorer function, BM25 in this case. And the documents that match boosted part of search expression will eventually get higher scores. On the slide, you can see the query we have already seen, but it's rewritten in a slightly different way. So instead of using in operator, I explicitly use disjunction and ask ArangoSearch to treat word brown as more relevant compared to word quick. So from geometry standpoint, that means we reduce the angle between query and document, vectors making document more relevant, like this. And I'm going to demonstrate how it actually works and what you can achieve using boost factors and tunable ranking in AQL in a demo section a bit later. Now let's summarize what ArangoSearch actually brings, and let's compare it to the existing full-text search index in ArangoDB. First of all, full-text index supports only basic Boolean expressions. Complex hierarchical expressions are not allowed at all. So phrase and proximity searches are not supported as well, no ranking, no analysis. Only one instance of full-text search index may have only one index field in a collection. And semantically, it has its own syntax, making it's quite hard, inconvenient, and even inefficient to use it in conjunction with other filter expression. But the only benefit, probably this crucial benefit for someone, the only benefit it has compared to ArangoSearch is immediate consistency guarantee. So, so the data is visible right after write transaction has been finished. In 3.4, ArangoSearch gives you only eventual consistency guarantee, namely it honors transactions, but there is a configurable delay between a successful write transaction and the visibility of written data. So now let me show how ArangoSearch works in action. And for the sake of this demo, I'm going to use ArangoDB dataset, which is taken from corresponding service. And the dataset actually consists of two collections representing a graph. There are more than 63,000 vertices and more than 225,000 edges. Both collections form a graph, and you can see its structure on the slide. There are vertices of different types in a vertex collection, namely actors, directors, and movies. And the edge collection represents the relationships between them. For example, an actor acts in a movie, or a movie is directed by an actor. But before we start working with views, let's get back to the analysis phase and look at how ArangoSearch analyzers are accessible via AQL. Let me switch to the web interface now. Okay. So, as was mentioned before, in 3.4, ArangoSearch ships with a set of built-in text processing analyzers for the most common languages like English, Chinese, German, French, Russian, and more. And for each analyzers, each analyzer performs language-specific tokenization and stemming. Unfortunately, there is no way to customize data analysis behavior in 3.4. Namely, all language-specific analyzers tokenize value into case-insensitive word stems as per specific locale, and do not discard any stop words at all. So in AQL, analyzers are accessible via tokens function, and let's see how it works. So actually, the function produced an array of tokens, and each token is in lowercase format, and it's stemmed. And for example, original word database was transformed into data bus. Okay, then it's also possible to tokenize some Chinese text, but in Chinese there is no such thing like stemming, so only tokenization will be applied. That phrase, actually, the input of the function is the same as it was before in the previous example, but it's ArangoDB is a multimodal database, but written in Chinese. Actually, there is another built-in analyzer called identity, and this analyzer is used as a placeholder in some functions if no analyzers was explicitly specified by a user. Identity analyzer does nothing but treats input value as an atom, so no transformation will be applied at all, like this. It simply returns the input value provided by the user. Okay, now we're ready to create our first ArangoSearch view, and to do that, I'm going to use ArangoShell. I'm going to switch to ArangoShell now. I am now connected to my local instance of ArangoDB. Let's check that there are no views in the database. Okay, there are no views. Then let's create our first view. Okay, and check that it was appeared. Okay. Let's check the properties of the view, or the created view, and see that the links field is empty, which means that the created view has no data at all, but it's already queryable, so the following query will return nothing. Okay. Yes, it returns nothing. So in order to index some data, one has to instantiate a link between the view and corresponding collection. And let's start with creating a link definition. Let's inspect it. So this definition basically describes the following intention, that we want to index every single attribute, every single field in every document in linked collections by specifying include all fields true, sorry. And apart from that, we want to apply identity analyzer to every field in a document except the description field, which has to be indexed with text in analyzer to properly tokenize and stem English text it contains. So now let's establish a link. It will take some time. Okay. As we can see, now view is connected to the corresponding collection, ArangoDB vertices. And now let's validate that all documents from linked collection are indexed by the view, and this query will return us the number of documents in the view. And let's check how many documents do we have in collection? Yes, exactly the same count. So now we set up our view, set up our database, and we're ready to start experimenting with queries. Now I'm going to switch back to my web interface again. Okay. So first of all, since we are working with IMDb database, we are mostly interested in movies. And let's count how many movies it has actually. Let's execute this query. Yes, and we got the result. Then we can specify search criteria to get even only drama movies. Since we already specified includable fields to index all the attributes in a documents, we can easily extend search criteria and be sure that ArangoSearch will pick corresponding index to create the best execution plan. Okay, or we can even get drama movies that are relatively short, so between, let's say, with a duration between 10 and 50 minutes. Like this, we restrict it a bit. Yes, there are only 35 such movies. Well, and as was stated above, again, there is a fundamental difference between searching and filtering in the context of ArangoSearch view. And let's now look at how these approaches can be combined. So this query gives you an example of that, and it will return all drama movies within a random duration interval. Let's check it. So it's random. Okay. This query shows you that you can use filter condition in combination with search condition to do some post-filtering stuff. Okay, so now let's look at something more interesting. So in 3.4, one can use ArangoSearch to perform to search for exact sentences instead of set of keywords in a random order. In AQL, phrase search is exposed via corresponding phrase function. And the following example gives us the documents that contain phrase Star Wars in the description. So let's check it, and let's perform search to prove Star Wars. So every single movie contains Star Wars phrase in the description, which is good. With the phrase function, one can perform actually different kind of searches, namely proximity searches, which is a way to search for two or more words that occur within a certain number of words from each other. Like in this example, I'm interested in the following pattern in the description. First of all, the in word, then the any other arbitrary words, and the galaxy. So let's check. Let's try to find this pattern. Galaxy. So in the galaxy, in a galaxy, in the galaxy again. So we can even increase this offset and see the results again. And let's check it. Galaxy in a distant galaxy. So two words in between. Okay, good. With the phrase function, apart from relatively simple proximity queries, one can perform really complex proximity queries like this. So in this case, we're interested in the pattern, in the following pattern. So word story, then two arbitrary words in between, then word man, then another two arbitrary words, then word undercover. Let's check it. So a man who goes undercover, story of a man who goes undercover. That's it. Then another very interesting AQL extension provided by ArangoSearch is min-match. Essentially is something in between of disjunction and conjunction. So it accepts multiple search expressions and numeric value actually denoting a minimum number of search expressions to be satisfied. Sorry. And the function actually matches documents where at least a specified number of search criteria are true. So in this particular example, I'm looking for documents which contains phrases Phantom Menace and Star Wars, or New Hope and Star Wars, or New Hope and Phantom Menace, or Star Wars and New Hope and Phantom Menace in its description. So let's check. And we found two movies which contains Star Wars and Phantom Menace, or New Hope and Star Wars. And in this example, as you may notice, we used phrase function 3 times, and we specified even specified text en analyzer 3 times. So this query can be can be rewritten a bit, can be simplified, so that it honors dry principle, so do not repeat yourself, and with the help of analyzer function. This function basically does nothing, but overrides analyzer in the context of the search expression with another one, denoted by a specified. So and it makes it available for search function for search functions actually. So by default, every search function that accepts analyzer as a parameter has identity analyzer in its context. So this function has identity analyzer in its context, but since this search expression is wrapped with analyzer functions, it imbues the provided specified analyzer into the context of phrase function. So this query basically returns exactly the same result as previous one. So, okay. So now let's look at how ranking works in action. Before that, I forgot another example. So ArangoSearch in 3.4 actually supports prefix query. So and it's exposed in AQL value with the corresponding in AQL via the corresponding starts with function. And with the following example, we are getting all movies which with titles starting with FOU pattern. Let's check. So every single movie contains FOU. Every single title starts with FOU. Okay, now let's talk about ranking finally. First of all, let's imagine that we are extremely interested in a nice sci-fi movie, and I want to find something that matches the following set of keywords specified right there. So it's amazing, action, world, aliens, sci-fi, science, documental, and galaxy. And let's check what will I get without performing any ranking. And as you can see, without ranking, I got the prime of Miss Jean Brody in the very beginning of the results set. So this is definitely not what I did want to watch, but nevertheless, you may get different results since it's not deterministic because we didn't specify any sort of condition there. So then let's try to improve the situation and specify and use the vector space model and BM25 as a weighting algorithm right there and see the results. And we can see that the first place is taken by strange strange religious movie. That's again something that is not particularly relevant to our query, and the reason is the following. In the query above, we just executed, we didn't explicitly specify sorting order. So the default value is ascending, which means that we implicitly asked ArangoDB to show us the most irrelevant results first, since lower scores mean less relevant results. And let's fix it by explicitly specifying our intention to get the most relevant documents first in the beginning of the result set. So we just fixed it, and let's query. Okay, and now the most relevant document is the most relevant movie is Aliens versus Predator Requiem. This is definitely better, and let's continue experimenting with sci-fi movies and see how boost function I've already described works in action. So the results actually we got from this query are actually nice, since Aliens versus Predator is like action and it's related to galaxies and so on. But what if we want something more relevant to outer space, the movie that can show us the beauties of distant interstellar galaxies? And for the sake of our interest to sci-fi movies, we can ask ArangoSearch to prefer galaxy amongst the other keywords. Let me show you. So in this query, I've just split the original set of keywords into two parts. So the original set, so I've just introduced important keyword and split it in operator into the disjunction, and explicitly asked ArangoSearch to prefer the word galaxy as a more important one. So let's execute it and see how increasing of the boost factor can influence to the result, to the overall result. And the winner is, in that case, is Star Trek, so it's super relevant stuff. Now, the last part of the demo, but not least, is about combining ArangoSearch with the different graph traversals. Since ArangoSearch is a multimodal, ArangoDB is a multimodal database, so it's a crucial point for us that ArangoSearch can be easily combined in a single query with any other documents, with any other data models. And this is, I believe, truly outstanding feature. At least I do not know other databases that can achieve the same within a single query. First of all, let's enhance our previous query, and this time we're interested in actors that have played a role in one of the most relevant sci-fi movies we got from previous query. So to achieve that, let's pass a result of the search query into a graph traversal. And in IMDb dataset, as was shown on the slide, so each actor is linked to a corresponding movie via edge of type role. Like Richard Yearwood has a role in Alien Tracker movie. So let's execute it and see. And we got the list of actors right there, according to our interest to sci-fi movies. We can even modify this query a bit to retrieve a list of actors per each movie, per each movie out of more relevance movie we just got from previous queries. So we have actors played a role in Star Wars, Ice Pirates, Star Trek, and we can even do it other way around. So we can retrieve a list of movies per an actor, like this. Sorry, like this. Yes. So, for example, Samuel L. Jackson played a role in the second and third episode of Star Wars saga. So that's all for the demo for today. Now I'm going to switch back to the presentation. So first of all, thank you for your attention. And now I believe it's time to answer some queries. If there are any questions in the chat, so let me check. There are quite a lot. So the first question is there any specific search index So yes, under the hood, ArangoSearch uses inverted index, and actually the architecture of the search index is inspired by Lucene. So basically, yes, we have some like common parts compared to Lucene. We have some outstanding features compared. So yes, we have our own search index. Can token catch special characters? Yes, it can, but since there is no way to customize analyzers' behavior in 3.4, so at the moment it's impossible. But at the moment, all language-specific analyzers are using ICU under the hood. So in case if you are interested in like tokenizations, I believe ICU handles it perfectly. How much disk space overhead is taken by creating a view for an entire collection and all fields? So that's basically a good question. It's obviously depends on the how much data do you have, but in general for textual data, I can claim that that ArangoSearch index occupies approximately 60% of the original data. Does ArangoSearch support phonetic dictionaries? At the moment, as I said, so it's related to the custom analyzer feature, and unfortunately, it's not yet there in 3.4. Can we also filter first and then use search? No, that's actually impossible. So you have to. So in general, you can do a join between two data sources. So first of all, you can perform usual filtering over the collection and pass the results produced by this node down below to the corresponding view node and search. But in general, using search as inner loop is not so efficient. So I can recommend to start experimenting with ArangoSearch, having hits as in an outer loop. Can it highlight search towards on results? Again, good question. So the underlying search engine can store such information for highlighting. It tracks positions and offsets, so it can be technically exposed. But as for 3.4, we do not support it. So fuzzy search. In case if you mean, so do you mean, what do you mean by fuzzy search exactly? But in case if you are referring to the Elasticsearch implementation or Lucene implementation, it's 11 stain distance. It's based on the 11 stain distance, so it's in our pipeline right now, but it's not yet there in 3.4. Regular query filter works also on non-indexed data, just slower. Do all keys need to be indexed for search to work? So basically, search will not will treat all the non-indexed key as non-existent. So it basically will not see it. We are using ArangoDB on social media platform, and we have several documents we would like to run on search. Is that possible? Or should we create a document with copied data from all other documents to perform a search? So actually, you can restrict the number of fields you are interested in. So a number of fields to create an index over it, and that's it. Sometimes, in case you have multiple collections and you're interested in combine data from different fields into one and perform the search by in order to improve ranking, for example. Yes, it's also possible to create auxiliary field, some artificial field, put all the data from corresponding fields you're interested in and just index it. So both are doable. I'm going to share these queries with us and we can try them. So yes, guys, we have a comprehensive tutorial on the recently on ArangoSearch, and I believe most of the queries are present there. So I'm going to post the link into the chat right afterwards. Another good question: does ArangoSearch work in a cluster sharded collection graph? So first of all, ArangoSearch is completely integrated into the cluster environment, into the cluster ecosystem in ArangoDB. So in cluster, it works a bit different compared to the single server. So in cluster, we have one physical index instance per shard, so that yes, it's scalable, same as all other things in ArangoDB. Another question: are there any plans to add fuzzy matching such as n-gram trigram weighting? Yes, it's in our pipeline. Unfortunately, it's not yet there. So probably we will share some news with you soon on the roadmap. To use search phrases efficiently, does the field should be indexed explicitly? So actually, in case if you would like to use phrase search of the field, you basically has to index it with language specific, one of the language specific analyzers. That's it. Can also filter first and then use. Yes, I have a collection of documents with an organization field. So I want a user to search his organization's documents only first. So then you can just filter out documents from the collection you're interested in, and then pass create a search condition and pass it down to the query hierarchy into the corresponding ArangoSearch node, ArangoSearch statement. Do you have any examples showing graph results after text search? For the sake of this demo, no, I don't have. This looks great. Will this video be posted on YouTube or somewhere so I can share it? I believe so. It's recorded, so I hope it will be posted. Yes. Is search case sensitive? So another good question. So it actually depends on analyzer you are using. In case if you are using identity analyzer, which basically does nothing, the search actually is case sensitive. But as for language-specific analyzers in 3.4, all these analyzers convert the input data. First of all, they perform tokenization and convert each token into case-insensitive stamped term. That's it. What is your current laptop setup? Your latency was low. So my laptop is Core i5 with 24 gigabytes of RAM and 256 SSD hard drive. So in case of there are no questions, I believe again, guys, thank you for your attention. If you like, please start ArangoDB and ArangoSearch on GitHub. And in case you have any further questions, please join our community Slack, and we have corresponding ArangoSearch channel on it. So yes, and apart from that, feel free to ask me directly in email. So I believe that's about to be it. Thank you again.